Imagine you finally build the startup you always dreamed of. Your website goes live and customers start pouring in. But soon you notice your site is getting slower and slower. You decide to add another server, problem solved, right? But well, not exactly. Now you got two servers, but how do you split traffic between them so neither get overloaded? That's where load balancer comes in, the traffic police of internet. So what's exactly a load balancer? It sits in front of a server like a traffic controller. Whenever a user sends a request to your website, the load balancer decide which server should handle it, keep things fair, and ensure no single server gets overloaded. Ensure consistent performance, helps scale server dynamically. The result, your website stay fast, reliable, and always available, even when traffic spikes. Let's talk about type of load balancers. First, hardware versus software. Hardware load balancers are physical machine. They are super powerful but also super expensive. Software load balancers run on regular servers or cloud instance. They are flexible, cost efficient, and what most startup use today. Next, load balancer could also be classified based on the network layer they operate. Layer 4 versus layer 7. Layer 4 works at transport level. It routes traffic using IP addresses and port. Layer 7 works at application level. It can inspect URL header, even content, and then decide where to send it. Together, these types gives you option depending upon your scale, cost, and how smart you want your routing to be. Now let's cover the key algorithm. First is round robin. Each incoming request is assigned to the next server in the sequence. Server 1, then server 2, then server 3, and then back to server 1. It's easy and ensure even distribution, but works best when server have similar capacity. Then comes a variant of round robin, that is weighted round robin. These extend the basic algorithm by assigning weights to each server on its capacity. A more powerful server gets more requests. This makes distribution efficient when server differ in power. Next algorithm is disconnection. With this algorithm, each new request goes to the server with the fewest active connection right now. It's useful when requests take different amount of time or server different power. Next algorithm is IP hashing or consistent hashing. The IP hashing algorithm uses the client IP addresses to decide which server handles a request. That ensures that the same client keeps going to the same server. Consistent hashing builds on that. When a server is added or removed, only a small portion of traffic needs rerouting, keeping things stable. So that's the basic of load balancer, the traffic manager that keeps your system fast, reliable, and scalable. We covered what is a load balancer, its type, and the algorithm it uses to distribute traffic. If you found this helpful, don't forget to like, share, and subscribe because we are just getting started with system design.